Hey, what do you say there, math leaguers? Welcome to week 4. I apologize, this is your midweek hints video. Usually I get the midweek hints video to you by like Tuesday night or Wednesday morning or whatever. It is Thursday morning, and I'm just now getting it out to you. So my bad on that. You guys have been doing a great job. This is week 4. I know a lot of you are coming back for session number 2. I know some of you are leaving us. We're sorry to see you go, but it seems like most of you are staying for session 2. Been doing a great job. The leaderboard looks great. Don't forget, there's going to be I'm going to make a video of like a raffle where we raffle some prizes. And like last year, I had somebody that won the raffle, and I sent them emails and everything else, and they never responded, and I never sent them their gift. So if you see this video and like even if you're leaving us, get on the site, check the messages, and check to see if, there'll be a video of the raffle, which should come out I think maybe this Sunday, okay? So anyway, we got that, and for this week's bonus challenge, again, hopefully you got the email and everything. If you're watching this, you're probably watching this after tonight, which is Thursday night, but it's the Kahoot with the team version where you can have like your buddies or your family members or whatever do it, and we take an average for your team instead of just like your score, just to make it fun. Like, see if your mom can do this stuff, or see if your big brother can do this stuff, or whatever. So now we suggest 3 people, but if you want to have 5 people do it with you, again, it's an average. So do it with however many people you want. All right? And you can just do it by yourself. If you do it by yourself, your average is your score. All right. A joke. We got to have a joke. This is one of my favorite jokes. It's a terrible joke. It's about really big numbers, okay? And, like millions, billions, trillions, right? So anyway, there's this guy, and he's on the bus or the train or whatever, and he's sitting reading his newspaper. And there's this woman who happens to be looking over his shoulder, just being curious and reading a newspaper behind the guy, right? And he's reading his section, like the international section, like international news, and something really bad's going on in Brazil, right? There was like a hostile takeover attempt, and 6 people were killed in the attempt, right? So it says, the headline says, 6 Brazilians killed in hostile takeover attempt. So she's reading, looking over her shoulder, and she starts crying. And so the guy turns and realizes she's looking at his paper. He's like, "Oh, are you okay, ma'am? What's wrong?" She says, "Well, I'm reading the headline." And he says, "Well, I know it is really terrible, but things like this happen all over the world all the time." And she goes, "Yeah, but 6 Brazilians dead. Isn't that more than half the population of the whole world?" Like a Brazilian. She thought it was a really big number. All right. I know it's terrible. All right. It's a good joke. It's kind of math. It's more about just bad grammar, not knowing words, but it's kind of a math joke. All right. I'm going to jump to problem number 10 because I already put it on the board. You'll get these a lot in math contests and stuff like that. The old style clock, the analog clock, you'd say what's the measure of degrees? Let me see what I have on. I got a similar time, 2:25. But on this one, I'm just going to say what's the measure of degrees formed by the hour hand and the minute hand at let's say 1:30. Okay. Well, if we think about it, there's 12 jumps, right? 12 to 1. There's 12 jumps going around the clock. When you go all the way around, that's 360 degrees. The 360 divided by 12 is 30. So that's 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees, and so on. Okay? So, if it's 1:30, the minute hand is right there on the 6, perfectly on the 6. The hour hand is halfway between the 1 and the 2. Okay? So it's right there. So how many degrees is this right here? That's 15. and then 30, 30, 30, 30. So 30 and 30 is 60, 90, and 15 more would be 30, 60, 90, 120 from 3 to 2, and then 15 more would be 135. Okay? So those are kind of simple, but a lot of times people don't know what that means when we're asking the question. All right, next question I'm going to jump to is number 6. I put it on this whiteboard. Sorry, it's really, really messy, but that's okay. It asks you, like, how many different triangles can you make with a perimeter of 15 inches? And so I just did like a similar problem, but with a perimeter of 11 inches, and I didn't do all of them for you. I just kind of showed you there's a rule that comes up very often in math contests where you have to know this rule that the sum of any two sides of a triangle must be greater than the third side. Not equal to, but greater than the third side. Think of an example like this. If we have a triangle that's like really small, 1 by 1, and then we're trying to get a perimeter of 11, well, we can't stuff 9 in here, right? Think about it. 9 would be like all the way across here, okay? So that's why you can't have a 1, 1, 9 right triangle. There's just not enough room. That's why the sum of any two sides must be greater than the third side. So if we start with the number 1, if we're just grinding it out and say, well, could we have a 1, 1, 9? No. Could we have a 1, 2? That's 3. That's not more than 8. No. Could we have 1 and 3? No. That's 4. That's not more than 7. Could we have a 1 and 4? No. 5. That's not more than 6. Okay. Can we have a 1 and 5? Yes. 6 is more than 5. 10 is more than 1. 6 is more than 5. If we start with a 2, could we have a 2, 1, 8? No, 3 is not more than 8. Could we have a 2, 4, 5? Yes, we could. Okay? 6 is more than 5. 9 is more than 2. 7 is more than 4. We can have that. Okay? All good? All right. I know I stuffed things in here. We've got one of our players in the league whose nickname, his player nickname is like something like I love Heron's formula, or I like Heron's formula, or something like that. There's a problem where I give you 3 sides of a triangle. It's problem number 8. I give you 3 sides of a triangle, and you don't know what kind of a triangle is. Well, it says it's isosceles, but like there's a special formula where you can find the area, even if you don't know what's the base and what's the height, just from getting 3 sides. But there's 2 ways to do it. If you have an isosceles, what you can do, so like it's a different measures on the one that I gave you, but let's say you had one that's 5, 5, 8. Well, what you can do is you can draw it like that. You can, if these are equal, then they're going to be like equal angles, and so we can draw an altitude straight down, split that 8, and that's 4, and then you've got like a little triangle that's a 3, 4, 5. Hopefully remember our right triangle triples, okay? So you can do it like that, and then you say, okay, right, if this is 5 and this is 4, that has to be 3 by the Pythagorean theorem, okay? So we know this is 3, so the area is 8 by 3, which is 24, but you cut it in half, so it's 12. There's also this thing called Heron's formula, where you take what's called the semi-perimeter, like half the perimeter, okay? And when you do the semi-perimeter, like 5, 5, and 8, well, that's 10, 18, half that is 9. It's called the semi-perimeter. You take the semi-perimeter underneath a square root sign, times it by the semi-perimeter minus one side, by the semi-perimeter minus the other side, by the semi-perimeter minus the third side. So it's 9 times 4 times 4 times 1, which is 144, and the square root of 144 is 12. So it worked, right? Isn't that cool? All right, that was number 8. Again, yours is different. And then number 2. Number 2. These are like systems of equation problems. It's like acid solution. I'm going to go fast through this one, but I'm going to do a much simpler one than the one that's on your sheet. This one's really simple. If I said how much 10% acid solution should be mixed with how much 20% acid solution to create 5 gallons of 15% acid solution. Well, if 15 is like exactly in between 10 and 20, so it's going to be half and half. We kind of know that. So it'll be like 2.5 gallons of this and 2.5 gallons of that. Okay, there's a fancy way to do it called systems of equations, where you say, this is a cup with the 10% solution, so like the 10% of that is acid. This is a cup with the 20% solution, so like 20% of that is acid. And this is a bucket with like 15% solution, so like 15% of that is acid, right? So you get two equations. The amount of stuff in here, x, plus the amount of stuff in here, y, equals 5. And the acid is 10% of x plus 20% of y equals 15% of 5, which is 0.75. I'm going really fast here. This has all these decimals in it, so I multiplied everything here by 10. So 1x plus 2y, 0.75 times 10 is 7.5. I rewrite this equation underneath it, and then I combine my equations. I don't know if you've ever learned this, but you can combine equations, combine like terms. So by subtraction, 1x minus 1x is nothing, 2y minus 1y is y, or 1y, 7.5 minus 5 is 2.5. We knew that was going to be the answer, right? Because it's a simple problem. There's another trick way without doing all this algebra. You could just, like, let's say instead of 15%, we were making an 18% solution. Okay? So think about this. 18% is 4/5 of the way between 10 and 20. Right? So how much are we creating? 5 gallons. Well, obviously it's going to be heavier on the 20% than on the 10% because we're creating a heavy acid solution. All right? So it's going to be skewed this way. 4/5 of it is going to be this stuff, and the other 1/5 will be this stuff. Well, what's 4/5 of 5? 4. What's 1/5 of 5? 1. So if you were making 18% solution, it would be 1 gallon of the 10% and 4 gallons of the 20%. Now be careful. On the problem I asked, I just asked you for like one of the two, and you just put in the number. Okay? All right. Coolio, have a great week.